In this example, we're going to look at some class data concerning pop culture, and I'm going to let you make your own hypotheses and then test them. So we have information on how much people like Justin Bieber, how much they like the Kardashians, and how much they like Star Wars. We're going to use data analysis and regression to test each hypothesis. So we'll calculate the R and see if it's significant. That is, if the P is less than 0.05. And so we should make one hypothesis concerning Justin Bieber and the Kardashian, the second with Justin Bieber and Star Wars, and the third with the Kardashians and Star Wars. So I'm going to make some, but you don't have to make these exact same ones. I'm going to do hypothesis one. I'm going to put this in bold so we don't lose it. Liking Justin Bieber will be positively correlated with liking the Kardashians. I think there might be some pop culture preferences being expressed here. So that's going to be our first hypothesis, and this is a one-tailed hypothesis. One-tailed hypothesis. As I said, it's going to be positively correlated. And why did that? Oh, it looks like that thought it was part of the table. Let's so this is going to be a one-tailed hypothesis. So we can put in here one-tailed hypothesis. Oh no, why does it think? So this is going to be a one-tailed hypothesis. So we'll put in here in parentheses underneath one-tailed hypothesis. All right, now let's run the data. Let's go to use our data analysis and regression analysis to get both the correlation and the probability. Data analysis, and we're going to do regression because correlation doesn't give us the p-value. So the input range is going to be Justin Bieber. We'll choose all the Justin Bieber data. And the X range is going to be the Kardashians. Let's choose all of that. We've got labels. The output range is going to be, let's put the output range down here. Press OK. And we've got a lot of data here. Now let's round off the numbers. General number. Okay, and make it a little wider. And bring everything over here. And so here we have the first thing that we're interested in is the R. So this is the absolute value of R. So it's 0.34. So it's not negligible, but it's not very strong. And here we've got the significance of R. And now remember, this is the two-tailed p-value. So this is two-tailed p-value. And so the one-tailed p-value is going to be half of that. So let's get some more decimal points there. Whoops, let's choose it over there. So 0.934. So we can say that the one-tailed p-value And let's do a little calculation here. This is Q15, so we're going to do equals Q15 divided by 2. It's 0.465. Oh, that's significant. It's less than 0.05. So we do have a significant correlation. Now let's check the sign, and we can see the coefficient for down here is 0.51. So we can say R is positive. So our hypothesis was supported. We can conclude that liking Justin Bieber is positively correlated to liking the Kardashians. And we've got Control R, and then we put in the degrees of freedom. Oh, so this is the degrees of freedom up here, degrees of freedom. And we put that in parentheses right after the R. 23, close parentheses, space equals space, 0.34, comma, space, then Control Control I, P equals 0.047. And that's two-tailed, that's a one-tailed test. One-tailed test. And so that's our conclusion that the hypothesis is supported. Okay, now let's make our second hypothesis. This one's going to be about Justin Bieber and Star Wars. So I'm going to guess that liking Justin Bieber, hypothesis 2, I'll put that in bold. Liking Justin Bieber will be negatively correlated with liking Star Wars. I think the more people like Justin Bieber, the less they'll like Star Wars, and vice versa. So this is a one-tailed test again, one-tailed hypothesis. We'll do a one-tailed test on it. So once again, we go to our data analysis, regression. And this time we're going to choose Bieber and Star Wars. Okay, we've already got Bieber in X. Let's go over to Star Wars and choose that. And we've got the labels and the output range. Now let's choose the right output range. Let's put it down here. And we press OK. Let's round off some numbers. Number format. And we have, ooh, look, R is 0.07. That's not very strong. So this is the absolute value of R. This is the significance 0.76. That's not encouraging. This is the two-tailed p-value. That means the one tail, let's turn off the italics. P-value. The one-tailed p would be half of that. That's half of 0.76 is 0.38. Ooh, that's not very encouraging. So it's not significant. Here we've got the degrees of freedom. that we need to report. We always need to report the statistics, even though it's not significant. And the coefficient was negative. That's what we thought. So R is negative, but it's not significant. Maybe if we had a larger sample, it would be, but this is too weak. It could easily be positive, could be negative. So we have to conclude that we did not find significant evidence that liking Justin Bieber is negatively correlated with liking Star Wars. And then we have to report our statistics, so comma, or we could put this all in parentheses, but it's better to not have parentheses with inside parentheses with these degrees of freedom. So Control I, R, Control I off, then open parentheses, and we've got degrees of freedom is 23, close parentheses, space, equals, and it was minus 0.07. Minus 0.07. So the negative sign comes from here. The value of R comes from there. So equals minus 0.07. And we've got Control I, P, Control I, space, equals 0.381 tails. So we don't have strong evidence that linking Justin Bieber to Star Wars. So that hypothesis was not supported. Now let's go for a third hypothesis having to do with the Kardashians and Star Wars. I'm going to make the same hypothesis, basically. So Control bold, hypothesis 3, liking the Kardashians will be negatively, let's spell negatively, right? Negatively correlated with liking Star Wars. That's a one-tailed hypothesis also. So once again, we're going to use our data analysis, regression, and we've got Bieber. So instead of Bieber here, we're going to put the Kardashians, and we already have Star Wars in there. Okay, and then for the output, we need to choose a new place for that. Let's put that way down here, I-54, and press OK. Let's round off the data, the number. Okay, so let's make this wider. And so we've got, R. So this is the absolute value of R. It's still not very high. Absolute value of R. We've got the degrees of freedom are 23, and the p-value is 0.75. Let's get that another decimal point, 0.754. So we're going to say, we can say that one-tailed p, one-tailed p equals, and then the next I'm going to put, this is n65 equals n65 divided by 2, because we made a one-tailed hypothesis. So this is the two-tailed piece. We have to divide it by 2. So the one-tailed p equals 0.38. So it's still not significant. The correlation is negative. So we can because the coefficient is negative, so we can write control I, R is negative. So our conclusion is we did not find significant evidence that liking the Kardashians is negatively correlated with liking Star Wars. And so we have control I, R, control I, and then parentheses, the degrees of freedom, 23, space equals, and so the correlation was 0.07, and it was minus, right, minus 0.07, comma, and then the p-value, control I, p, control I, space equals, space 0.38, one-tailed. So once again, a non-significant correlation. Well, we've tested these three hypotheses, and one of them was significant.